morning, everyone. I hope that you had a good Easter and ready to come back to work. We have done all the derivative rules for this unit. We learned about derivatives of e to the power of x, a to the power of x, ln x, log x, and sine, cosine, and tan. In today's video, I'm going to summarize all the derivative rules that we have learned in this unit. Then I will give you some tips related to how to simplify or how to do complicated logarithmic derivatives. And we almost done with this unit. After this, we are going to have one lesson about the application and word problems. Then we are done with this unit and also with all the calculus, and we're going to start vectors. Hopefully by the end of this week we are done with the derivatives, with all the calculus curriculum. And today after I finish this video, I will post it on SB, and also I will give you an assignment, and this is the last assignment before the midterm mark. So I want you to do it and send it back to me by tomorrow at 7 p.m. Okay? Alright, so I will summarize all the rules that we have learned. So review of unit 4. The first thing we have learned, if f of x equal e to the power of x, f prime of x will equal e to the power of x. If f of x equal a to the power of x, f prime of x equals a to the power of x ln a. Then we learned about the ln function. So if we have f of x ln equal ln x, f prime of x will equal 1 over x. If we have f of x equal log x base b, f prime of x will equal 1 over x ln b. Then we learned about trigonometric functions. So if f of x equal sine x, f prime of x equal cosine x. If f of x equal cosine x, f prime of x equal negative sine x. If f of x equal tan x, f prime of x equal secant squared x. Then from these rules we found 3 additional rules. If f of x equal cosecant x, f prime of x equal negative cosecant x, cotan x. If f of x equal secant x, f prime of x will equal secant x tan x. And if f of x equal cotan x, f prime of x will equal negative cosecant squared x. Okay, those are all the rules that we have learned in this unit. I recommend that you write them down, and you must know how to prove the derivative, that the derivative of tan is secant, the derivative of cosecant is negative cosecant cotan, the derivative of secant is secant tan, the derivative of cotan is negative cosecant squared, because those are evaluation questions. Also, I want you to know how to prove that the derivative of ln x is 1 over x, and the derivative of log x is 1 over x ln b when the base is b. Those are important things. I'm not going to ask you about them, but it is good to know them. Remember the important limit that we learned at the first or the second video. So those are the rules that we have learned in this unit. And of course, also we used them with chain rule sometimes, and how to do that. So for example, if I have f of x equal sine to the power of 4 of 2x squared plus 3x plus 5, how can I find the derivative of that? The derivative of this will be, this is like g of x to the power of n, so n g of x to the power of n minus 1 times the derivative of g of x, derivative of sine this, derivative of sine anything is cosine that thing, times the derivative of whatever inside, which is 4x plus 2. Okay, and this applies for all the functions, the same idea, if it's cosine, if it's tan, if it's log, anything. Okay, so I just wanted to remind you of this too. Another thing I want to remind you, when we do derivative of log or ln, try to use the laws of log and ln to make to simplify the derivative. Like, for example, let's say f of x equal ln x cubic root of x squared times x squared plus 3x plus 2 over x squared minus 5. Something like this. When you have one log or one ln and all of these inside, you can find the derivative using quotient rule, and then when you come to the derivative of the top, you do product rule, but this will be very, very hard. The best thing to do is try to have as many ln's as you can. That when you have ln's added or subtracted and using quotient rule of ln or product rule of ln or the power rule, this will simplify everything for you. So let me give you, show you how to do that. When you have something complicated like this with ln and log especially, try to have as many ln's as you can. So I can write this using product and quotient rule as ln the cubic root of x squared plus ln x squared plus 3x plus 2 minus ln x squared minus 5. Okay, I just used the product and the quotient rule to separate those logs and ln's. Okay, now we have 3 ln's added and subtracted, and this will be easier to find the derivative. So again, I can write this as ln, instead of having the cubic root or rational exponent, I can write this as ln x to the power of 2 over 3 plus ln x squared plus 3x plus 2 minus ln x squared minus 5. Then I can find the derivative. Still, I can use the power rule and send this over here. So 2 over 3 ln x plus ln x squared plus 3x plus 2 this ln's added and subtracted and using the power rule, so I can find the derivative much easier now. So now if I want to find f prime of x, 2 over 3 will be here, derivative of ln x will be 1 over x. Plus, the derivative of this is 1 over x squared plus 3x plus 2 times the derivative of whatever inside, which is 2x plus 3. Much easier. Minus the derivative of this is 1 over x squared minus 5 times the derivative of whatever between the brackets, which is 2x. Now we can write this as 2 over 3x plus 2x plus 3 over x squared plus 3x plus 2 minus 2x over x squared minus 5. The mistake that I don't want to see is somebody cancelling the x and the square. You cannot do that. And here also you can only cancel out factor terms that are multiplied with each other, not added or subtracted or like that. So you see, this is the derivative after we did the simplification, after we made many ln's. So put that in your mind when you are doing the assignment. Always try to have as many as possible of ln's. That will make the derivative much easier. Okay, I will post the video, I will post the assignment, send it to me before tomorrow 7 p.m. and have a wonderful day.